Hello and welcome to another biology lesson. Today I want to look at the process of speciation some more and talk about it a little bit, give you an example of it that should help with the next assignment. The example I'm going to give is actually quite similar to one in the book dealing with the Galapagos finches, but because it's me, it of course has to be flostriches. But first, before I get into it, I do want to address a misconception that I have been seeing, and it's very much relevant to this example. And that is that mutations are random events. And a lot of people have been describing mutations for, say, the bacteria population as if, hey, the bacteria needed to mutate to become resistant, so they did mutate. And that's not how it works. And organisms do not get the mutations necessarily that they need. That's why they go extinct. At least that's one of the reasons they can go extinct. And so if you look at populations, if they are unable to get the adaptations or the mutations or the changes they need to be able to adapt to a changing environment, then they will go extinct. So there's no guarantee an organism is going to get the mutation that it needs. Mutations are random. You could have, for instance, the peppered moth get a mutation to turn it black, which is great because it helps it blend in with the new blackened tree trunks, but it could have just as well got a mutation that turned it bright pink, which wouldn't have been very helpful at all and probably would have led to that particular allele being eliminated very quickly. And just because it needed to turn black doesn't necessarily mean that it would have got that mutation. In this case, I'll talk about that more in a minute. And so let's look at our population of flostriches. Let's say I have an initial population on this island, and these islands are relatively isolated. So a small group is able to eventually start a population on this island and say on this island. But because it is so difficult for these birds to move from one island to another, they're essentially isolated. In other words, this population will not reproduce, will not be breeding with this population. So there will be no exchange of genetic material. So one of the key things in speciation is going to be some amount of reproductive isolation. That's so important because whatever mutations that happen here, because they are random, won't be shared with this group. And whatever mutations happen here won't be shared with this group or this group. And so that'll be true for all these groups. None of the mutations will be shared with the other groups. And again, that's key because the mutations are random. Each group will be getting different mutations. And it's entirely possible that they all would need the same mutations, but they won't be getting the same mutations because it's random. So let's say we have this initial population here. The pink colored birds, hooked beak, normal sized wings, what have you. Now this population over here gets a random mutation that makes them more camouflaged, and that allows them to eat different foods that this population originally couldn't capture because you would need to be able to be camouflaged to catch that particular prey. And so maybe this is just hunting, like flamingos hunt maybe shrimp and other things that are buried in mud. It doesn't really matter if they're pink. But this population, they start hunting mice and frogs and other things in the middle of the island. So they're able to take advantage of a different resource. That's an advantage. Maybe they also get a random mutation that shrinks their wings. That's an advantage since this is a flightless bird anyway. And so the smaller the wings, the less likely the wings are to be injured or become infected, the less amount of resources that need to go to supply nutrients to the wings. So that'd actually be an advantage if they're not using the wings for anything anyway. So it gets those mutations. Now that small wing would actually benefit all three groups because they're all flightless, but this is the only one that got that random mutation. Let's say this population got a random mutation for a slightly different beak shape, a little bit more like a duck, and that allows it to then eat different food from the original population. Again, random. And so, we given it enough time, these populations have now become enough different that's entirely possible if this population were to somehow return to the original island, that it would no longer view that original population as as being the same, and so they still wouldn't interbreed. They would look at each other and say, that isn't what a mate looks like for me. It could even be more extreme, that maybe their mating cycles have changed. Maybe that one of the random mutations changed when they mate. So maybe they mate a month earlier than this population, or what have you. And so that means that even if they mix back together, then they are no longer going to interbreed. They're still not going to exchange DNA. They're still not going to exchange genes. They're still going to have that reproductive isolation, which is the key for that speciation. So they'll continue to mutate differently and change separately and become more and more different over time. And the same could be said up here. And interestingly, and this is kind of what happened in the Galapagos, is these populations could, this population could come here and this one here, and I could end up with all three species on all three islands, or different mixes on different islands, because they can move, but they just don't do it very often. All right, so that's kind of what we have. The key there is that reproductive isolation, and then that random mutation. And then, of course, after that, it's just the process of natural selection, like we've seen before. The mutations are going to create new variations here, new variations there. Some of those variations will be better than others. The better variations will become more common. The less ones will be, the worst ones will become less common. But that process will be different in all three places because there are different random mutations. Even though we would expect these three islands to actually be fairly similar environments. So anything that was a benefit here probably would be a benefit in the other two places. All right, I'm starting to repeat myself, so I'm going to stop. I hope this is helpful. Please let me know if you have any questions, and thank you for watching.